Good morning and welcome back to Cooking with Cale. My name is Cale, and today we are still dealing with the error that I made in the ASCII data specification on how I handle strings. Because the way that it works is we have, with the ASCII data specification, we have to map one type to another. And we have a total of 500 or 200, 512 types that we can map to with a choice of 31 different plain old data types. And so the reason for that is, well, we have a null type in the POD table. And this is a little bit of a bugaboo. I don't really want to occupy an entire slot in the POD table with a null type. It does create more extended ASCII data types, though. So the data types are not lost. They just, the thing is, we have these context types. Oh, yeah, first off, where can you find this at? You can find this at github.com / Kabuki Starship / Script2. And having a late start today. Keep going. I'm looking at stuff I can't afford on the internet. Bah, I'm tired of it. I need to make more money. Like, being poor is can occupy a lot of your time because you can't do things, right? Like, you could have had a good job, you could have made all that money in a very short period of time that you're trying to save. So, yeah. So what do we got? So originally, in order to make a string, I thought I was going to map a character to a another type. It's not too bad. So what's the problem with this? So the problem is that we have some peculiarities with Unicode on how you print and store strings. And that is that with UTF-8 and UTF-16, you must uncompress UTF bytes. So if I want to look up something in like a do an array lookup of a character, I would have to scan through the whole thing. I couldn't just offset. I would have to scan. So each operating system is going to store the Unicode differently. There's no standard way for operating systems to handle Unicode. And this leads to a number of design choices in C++ that are suboptimal, that are from legacy code. And from what I gather, talking with people, people's biggest gripes with C++ are the data standard sucks. The long, long thing is stupid. Nobody knows what it means. Uh, the memory management can be tedious and cumbersome and can yield some bugs, which, the new version of C++ will be fixing these bugs. I think we need to have a divergence. I think I'm going to take whatever code they have for deterministic memory. No, that's not what I'm trying to say. For memory management and like safe memory management, right? Well, quote unquote safe memory management, which you can just do with an API. There are ways to go about doing memory safely in C++ that do not require you to use Rust, such as a round robin server where you're dealing with all of your asynchronous operations in a round robin loop. This eliminates the what am I trying to say? The memory race, the race condition with the memory, multiple things talking to each other because you can just process one thing at a time, and then you pass off whatever message to another thread, or you dispatch the message to a thread. Right? There's ways of doing this. I just hate how they want me to throw away all my code. They're like, your code sucks. It's garbage. It doesn't use Rust. It's not safe. It says the government employees and the contractors trying to milk the government. Right? What am I doing? I'm going to restart this, dude. So, what can we do here? What's the problem? So, the problem is there's multiple ways to store strings. So, you have your extended types. Not this. This is the mappable types. So, these ones you can map to. And then there's other ones that cannot be mapped to. Such as a dictionary, because a dictionary itself is a map, and a book itself is a map. So you would not map something to a dictionary. You would just make a dictionary. So we have in the beginning, oh, that's the wrong table, right? There's the non-mappable types. And then, hold on, where's the string at? Here we go. And this is the extended standard types. So there's the extended mappable types, which are we have POD types at the top. We have in the columns a bit pattern that repeats vector homotuple 1 through 4, which are 1 through 4 of the same type next to each other or contiguous. An array, stack, or matrix. That could be 8, 16, 32, and 64-bit. And then we have these illegal memory addresses because it's not word aligned, such as a 8-bit array of 16-bit types right here. These 4 ones, it's an 8-bit array of 16-bit types. So you can't store an 8-bit array of 16-bit types because you need to use a 16-bit type because it's not going to be memory aligned. So this gets remapped. Oh, so where's the map? These are the extended mappable types, the zeros. All right. And then we have we repack them contiguously using a pretty clever bit shifting algorithm that I'm very proud of myself. I like it. I think it's great. Kind of reminds me of a K-map. So we have some. I like this a lot because I cannot make a map of a string to a Unicode nil terminated string because it doesn't specify the size at the beginning of the string. Right? So when I see this, when I say, you can just kind of forget about my API, the Chinese room abstract stack machine. When you're looking at this, this is on the lower level than the Chinese room abstract stack machine. There's no remote procedure call here at this point. We just defined data. All right. And so these extended standard types, they cannot be mapped to because they're not in the first, they're not any of these types. And so these plain context types A through L, they can be remapped to any of these types. So you can remap it to an illegal type, and then you can create your own bit pattern using that. But that's up to the user's implementation. I don't handle that. I just show you how to go about doing it. But I like that because it allows us to do things such as like, use a plain old data type to so let's say we have like a 64-bit timestamp, right? And so we can make one of these remap. So my timestamp is different. My timestamp is optimized for x86 and SQL and hard drive inode lookup for SQL table rows. And so I use 32-bit timestamp and 32-bit sub-second ticker. And instead of a 64-bit timestamp. And then I use 128-bit linear ID, UUID, for the 128-bit TME timestamp. The plain old data table. So this one. So I would want to possibly create a 64-bit timestamp that is just maybe a millisecond. So you don't want to use a millisecond timestamp or any sub-second timestamp with SQL or anything that references things using the Unix timestamp, because you are going to have to divide that number by 1,000, and this is just bad news bears, dude. You don't want to do that. So instead, instead of using my superior timestamp format, well, it's not my timestamp formats. I mean, I yanked them from. Well, I can't. The linear ID thing is mine. That's my UUID format, which is superior. Better on all. It's like faster. It uses a lot less power. Cheaper to run. All right. So then I have to take. I can take these with these plain contextual types. Contextual. I don't think it's contextual. So I can remap those to one of the other POD types. Where's the in selection? I hate it when it does that. Why? What the hell is it doing? Bunny's ripping up her bunny house. What is she doing? Do I have a bunny cam on her? What are you doing over there, bunny? Being a bad girl. She knows she's being a bad girl. I don't have the bunny cam set up, unfortunately. I do need to get that set up. Good enough. She knows she's not supposed to chew and she still chews, dude. I don't know what to do. The other bunny, Carol, she never chews. She's like a really good bunny. And then Sugar, she chews on everything. What am I saying? Okay, so the different ways that we're supporting strings are that we have an array of characters. There she goes again. All day long. I gotta pull out the broom and go chase her away from the side of the house. She's like destroying her bunny house. Sugar, no. Have to do that at least 20 times a day. She's a good girl other than that. It's just something you gotta know about bunnies. Some of them are chewers. All right, so I have. What is the problem here? I have to revert back to the pre-T Sprinter code. So in this string format, this is an array of characters. Let me explain this because this doesn't. Oh yeah, you weren't even able to see the code. So I have with my bit pattern. I have these modifier bits. These can be disregarded. Map type, size width, vector type, plain old data type. All right, and then so the map type, if we want to make a map of a string to another type, we just set one of the POD types to a character type. Sorry, the map type set to cha A, cha B, or cha C, which is your 8, 16, and 32-bit Unicode. So let's say I just want to make a string. Okay. So what are my options? My options are I make an array of characters. So my array of characters. So here's a little bit of a problem. We have 512 standard types, and we need to make as many different kinds of apps and firmware as we can out of the data types. So it needs to be like maximum. Like I need to do AI with it. All right. So with these data types, what we know is that we're at least going to have access to them within inside of a dictionary or a book, which is a multi-map. It can have multiple key value pairs of the same key. This is superior for push performance. You can then convert that into a hash table. You could do a. We have how many types of dictionaries? There are not all combinations of dictionary types are not legal, so we stuck those in the extended. What is this? The mappable types. Right. What do we got? Oh man, what happened? All right. So here's the mappable types. So I can. These are the ones that I could map one of the other plain old data types to this or a string. You cannot do a character. We reserve, in order to make the map of a string to one of these types, requires us to not be able to make a map of a character to another type. We just had to replace that with the string, which, it is what it is. You can make that in software. You can do that with the app, with the API, but you can't transfer that with RPC. You're going to have to, in order to do that, you're going to have to take a an array of signed integers to do that. So there's other ways to go about doing it. We just have a bit pattern, and we have to make it work for as many people as possible. All right, so we have our dictionary types. There's only 3 different ones that make sense: the 16, 32, and 64-bit dictionary. And then there's 3 different variants based upon the data type: 16, 32, or 64-bit for DTD. Still got some reserved values, and then we get the big int down here. And we have, clearly we have a pretty big gap here. Or no, it's just not numbered correctly. No, it's just not numbered correctly. All right. So what does that mean with the goal at hand? So this string, the thing I'm trying to hash out is a little bit of confusing nomenclature and with dealing with the strings. So this string class is an array. So this means it's an ASCII array. Hold on. This means that it could be an ASCII array or an object. The difference is that an ASCII array stores the element count as the first ISI as opposed to an object which stores the size in bytes. So this, I had mistakenly had this. So when it says bytes, it means it's an ASCII object. And I accidentally had that saying bytes when this one's a total. Total means that it's an array. The reason for that is that count is 5 letters, and then total is 5 letters, and it works. So if you are going to make an array of characters, with the bit pattern here, we would set the vector type bits to array, which is 0, 1. Then we're going to set the size width 8, 16, 32, or 64. The map type is going to be null. The modifier bits, those are going to be 0, 0, constant. That one's like if it's read only or not. Basically, we make if it's read only, we make it negative. So if it's negative, you got to multiply it by -1 in order to get the bits. Then we got 32 and 64-bit data types. And so the Super 32 and the Super 64 types, those ones are not fully fleshed out because there's quite a bit more memory address space. I am able to store and create, I'm doing kind of like an ARM instruction set type of deal where I can store some numbers in the data type using the mod bits. So there's multiple ways to make a string though. So we've got an array of characters. We also have a stack of characters. Well, I mean, I could just cut off the array of characters. I could just make it so if you want an array of characters, which is useful for printing. The difference is that we have to define it with the bit pattern. It has to be defined. A string has to be defined with the bit pattern, which could be an extended type. Like it could be in. We'd want a mappable type, right? Wait, a book is a mappable type. You could think stick it here or something. So we have Unicode. Here's the problem. So we have Unicode where UTF-8, UTF-16, and UTF-32 are encoded. Oh, sorry. UTF-32 is not encoded. I apologize. But so we need a different data structure for UTF-8 and UTF-16 than we do for UTF-32. So when you are printing to these strings, you're going to store the number of elements in your buffer, and you're probably going to want to store the character count. Sorry, the number of used characters that are in it, as well as the character count. So this is where my task lies with this, is that I only have, for some reason, I only have the basic string and the auto string. And so this has been getting me by pretty good. But there are situations where this is suboptimal. So what's good about this? So through the usage of the basic string, I'm able to add this string printer. And the string printer is dumb. And it only stores the start and the stop. And so this can be used for UTF-8, 16, and 32. So this is the benefit. But then the drawback is where did that string go there? So the downside is we have our buffer here, right here. Here, this is gonna have to be like this. I'm gonna have to switch these because we would have a gap in the. Why would I just do? If I did not do it like this, then we're gonna have a buffer here, and then we're gonna have pointers. Pointers would be below that, so I cannot have that. Which means I'm gonna have to go through here in the highlight that. How many do I have? Wow, there's a lot of them. And then sprinter stop. Okay, now this is fine because I'm just doing the A array. With the auto array is what that means. ARY is array. Sign. Okay, I mean this is fine. This should just be a drop-in replacement. So the sprinter has the pointer. This makes up for the fact that this is just the struct T string. This is only storing the elements in the buffer. So what's the downside of this? So there are a lot of cases where I would want an array of characters, and I would want to just like print it out. But an auto string, this one has some cool template magic stuff to give me a static or a buffer on the stack. The other thing that I could do is make another one of these. Maybe I'll call this one the strand. Or maybe I'll call this one the string. What is the string? Null terminated string. Okay, so then we got a array of characters that only stores the size of the buffer, but it does not store the number of characters in the string, causing you to have to scan through the string in order to get to it. So one of these has to be strand, one has to be string. All right, so what I would need to do here is do this one. this would be an ASCII object. Here we're going to put easy bytes, and then here total. Okay. Oh, I don't have. Hmm? Is C. I don't know about that for strand. Not too bad. Okay, maybe. Oh, but then now we got to define. And so the problem with this one is we have 3 values. We need it to be memory aligned. So the ISY is your biggest signed integer. And then an ISY is half of that. Oh. All right. Wait. Hmm? Oh, wait. No, it isn't one of them a character count? Oh, right. So this is not right. Um, so what's the problem with this? No, because I need the character count, right? Count, and then char c, char count. Okay. This will work. Hold on, with the total and the count being what do I not like about this? So let's say I'm trying to conserve the space in the string. So I only want to do like a 64 byte header. And so that this is the header. Oh, I put everything's a boofer now. Oh, did it again. Sometimes, man. How many did I get? All right, so the problem with this is wait, no, it should be fine actually. The okay. So in order to make, I think that we could do the stack of characters. How do you do that? So take my bit pattern, use my vector type bits. I would set that to 2 for a stack, and then for a POD type, I would then set it to cha A, cha B, or cha C. So making an array of characters, I feel like maybe I can just not treat that like a string. I can just say that that's an array of characters because I have a need to print arrays of characters to the console quite often. I like that justification. It actually makes quite a bit of sense in order for me to do that. So, then we could just treat a stack of characters as a string. Where are strings? Are those in the I'm sorry. This should be something that's like in its own file, right? Map type. So how are strings represented? There's no way in hell there's no string one. Because this file's getting kind of big. 176 lines, not counting. Like that's pretty big. You know, if you look at the web page, the markdown output. So I have one for numbers. So let's make another one for strings. I'm a little bit disappointed that I don't have this. Strings. I don't know. I have no clue why I don't have one for strings, to be honest. Wait, what was that one? What extended types? Extended types. All right. So why is an array not really a good data structure to store a string? Because I can only store the element count, and that element count is not going to tell me where the null terminator string is. So I could take an array of characters and just throw a null termination character in there. That's not really a problem. The problem is more like utility of with the limited bit pattern, limited number of data types that we're going to need in order to make the widest variety of data types for apps that are going to be useful, that we need to transfer via RPC. So you got to imagine we are a souped up JSON here. All right. So this souped up JSON, you can imagine that we have key value pair tags, and that we are not trying to like do anything weird in the JSON. We're trying to make it so it's like, yeah, these are things that we use when we're programming a lot, and that's why it's in the standard. Right? So what about an array of characters? So like, when do I make arrays of characters that I don't treat as strings? Okay, so the most notable is the whenever I do key tables, I will take a multi-dimensional array of characters, and I will put my strings in there. So I'll make it all like 16 characters wide. So all the strings would be less than 16 characters because you're gonna have a null termination character, and a lot of times, most of the times, that's perfectly fine for my key tables for the strings. So this is something that I would like to keep supporting. So we do have a matrix. We have the matrix in here. What do we have? Not much in here. So we have a header, and then it is okay. Oh no. Hold on, what is this? So it's an SIZ dimension. Size dimension. Okay. This is not right. This is so old. Oh no! Sorry. Is that the way it is now? Uh-oh. I hate when that happens. I have to do all this other crap. Ooh, that's actually pretty good. Alright. Uh-oh. What is this? Yeah, I can't do this. T stack. What was that? What is it? Izzy? Shoot. Where am I even at right now? The Matrix, right? Well, okay. So, what does this mean for the bytes, elements, stack, number of matrix elements? Huh? Why is this like this? Because this is, oh, T stack. So the reasoning for this is that it has to be word aligned. So you have to have 1, 2, 4, or 8 of these things. These data, plain old data types, in order to be word aligned on all the systems. So this stick, isn't the index different? Is there an is-y in here? Yeah. So the is-y is your index. That's half the size of an is-z. And you can set the is-y to be the is-z if you would like. doing. I'm not too happy with my performance today. I wanted to get farther, but I can't keep like trying to explain things to people who are watching. It just doesn't do good. T-string. Too many template arguments, huh? Damn, bro. That's deep, bro. It's TRP. Well, I'm just gonna have to name. Wait, T-strand is just gonna have to go back to T-string right now. Or wait. No, T-string goes to T. I don't like how there's multiple of them. I don't really want to have a string made out of a stack of characters as well as a string made out of an array of characters. Because if you ask me, that's like getting to be really confusing. So then we have the need for the UTF 8 and 16 strings to have a different data structure because they can be encoded. And so they need to keep track of the character count. So I think I want to bump down to 2 different types of strings. We'll say that they're both strings. Maybe one's a strand, one's a string. But it's so confusing because isn't a string just like a null terminated string? You know, you got to set like the data specification exactly like what we're expecting here. This thing should just be yeah, I don't really like this. What else would we call it? String, strand. Now I could call the UTF-8 and the UTF-16 strings strands, and then I can get rid of this, and then I can just call the one that's a snack of characters a string. I feel like that would work, but I'm the kind of person that I don't really think that because you feel something that you should do it, because I have a very impulsive mother and she feels like doing things all the time that are just ridiculous. And um sorry, definitely not into the impulsive behavior myself. I've had enough of the impulsive behavior. I'm everyone finds it to be frustrating. Okay, so I'm going to have to do that because I don't want 3 different kinds of strings. I got a strand and I got a string, and I can't even think of another name to even call this thing. So I'm going to have to sit here and update this because this is just not acceptable. Like, this is a strand, this being called a. Here, let me just rename get rid of, zap that T string thing. Okay. What does this need to kill the whole project? We're rough riders around here, bro. Okay. I can just get rid of this one. I can just say this was not panning out. But herein lies the problem. The code works with this data type. So I have to like redo it. So where's the problem? Okay, so we have our grow code. So we're printing an item to this bad boy. And then we need it to grow. All right. Come in, growing the thing using our RAM factory. And then I switched over to the array copy because I was doing a string print, which I found to be, I didn't really want to do that because I'm having to walk the string. And I would prefer to just copy the memory using an optimized memory copy function. So the problem is that whenever I don't store the number of characters with this old one, I just had the total. If I don't store the number here, the total and the count, then I'm unable to calculate the array copy thing. I'm going to have to go back to walking the string, which is what I'm trying to avoid, because I want to copy the string over in word-sized chunks. And whereas this code isn't really that bad for this string, using the string copy function, it's not horrible. But then we're stuck with this crap where we are going to have to deal with the Unicode character count with the UTF-8 and the UTF-16. So functionally, I have to have I'm going to have two different classes. So this one's going to have to be a UTF-8, or sorry, UTF-32 only class. So a string. Wait, hold on, stack. And so this is going to give us, this is going to work great for an ASCII string or a UTF-32 string because you don't have to decode either of them, or an extended ASCII. Okay. And then this is the one that we're going to have to use for the UTF-8 and the UTF-16. And this one's going to have to be T-strand. And it's going to be nil terminated UTF-8 or UTF-16 string. Okay, because I don't want to give up any extra of my extended data types in order to deal with our string. So I think that we can get away with, I mean, are people really going to need to create stacks of characters that they print out the stack of characters to the string, to the console? I mean, you would just say that that's a string, right? Pretty sure you would just say that that's just a string, right? A stack of characters. Can you think of an examples where a stack of characters is not a string, or where it was like, okay, so we could safely say an array of characters is something that I would actually want to print to the console with without a null termination character. I'd want to print all the characters because I would either want to print them as numbers or I would want to print them as a Unicode value, which is both of them are perfectly acceptable. So I like this is what I really like about this API. This is my favorite thing is that is kind of like harmonious perfection. It's like we only have so many bits. You know, we have 512 different mappable types. And then we can make maps from the other types to those mappable types, as well as some extended standard types that you cannot map to, which makes perfect sense given the requirements of having a string that is just nil terminated in our extended bit pattern. Because when we have a string in our extended bit pattern, right here, this allows us to add, oh no, time's up, MSB variant encoding. And the MSB variant encoding is an extremely powerful way to compress data for integers because you use the MSB to load the next byte. And that's great. And so we also have the true and the false. So instead of having a Boolean type, we're using two types that have a true and a false. And then so we'll just treat two types as a Boolean type. So, but the thing is, I can't really make a map of one type to another. So I might actually have to move these to where's the other blocks? Did it get collapsed? I hate it when that happens. Are these the mappable types? Extended mappable types. Okay, I totally could do this because a true or false map is something that I might want to invest some of my types into. We have very limited ones of these. So I'm very frugal with this. But we could do this. Invalid. Yeah, but why do that? Wild card. So that's the any type. What does the any type mean? It means it's a type value tuple. Okay. So a type value tuple. What I want to make it I would want to make a map of something to a type value tuple. I could get rid of the invalid. Is the invalid, hold on, extended mappable types. Where are those? Wait, can I get rid of the invalid? Nil. Invalid. The extended mappable types are going to be these blocks, so I'd have to get rid of these. So this is always going to be nil or false. I could just say that nil is false. So let's say I give you a type and No, I would not be able to do that. Let's just go back to remapping these other things. Where's another section 2? Okay, so these, we'll just set these here because we don't have a Boolean type. So I could either stick these in, the options for the Boolean are you remap a context type to another plain old data type. Option 2, we use 2 of our extremely precious extended mappable types for Boolean true and false. And what functionality is this going to provide us? This is going to provide us with the functionality of being able to create a map of one type of one POD type or a string to a Boolean value. So I might want to say, I got string foo. Is this true or false? Okay. That seems legit. That's going to take 2 of my extremely precious extended mappable types. So is this more beneficial than, let us say, that instead of doing it this way, I instead used one of my plain context types in order to create a Boolean type. This is something that I can do, and this is why I went about doing it this way, because there are 16-bit and 32-bit Boolean values. And so in order to, rectify this, there's numerous strategies. I wasn't happy with the last strategy. So then we switched over to this plain context. This was, in fact, why I came up with the idea of the plain context types, because it was just such a struggle to fill up the whole plain old data type table. And then it's like the stuff that I was sticking in there, only some people would use. So it's like, okay, well, why not just make that swap out within the context that you're in? And you could just remap it, and that makes it like really easy for me to remap one of these types to one of these other 2 types. And then, if I want to make a Boolean type, then I could just remap it to one of these types. Okay, so what's the downside of that? The downside of that is that whenever I do that and I expose one of my plain context types, you can see I got a whole row now. Chunk, boom, 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 boom. Now I'm taking out a large amount of other data types that I could have stuck in here, because you got to think, we only got 512 of these data types here that we can map to, right? And so it's like using up 2 of these extended data types is better than taking up an entire row here, because we can at least say, but there's also another option though, because there's so much stuff that you can do with ASCII data, it's like crazy. The other option that we have available to us are the extended blocks. All right, and so the extended blocks, you're going to get access to these extended blocks utilizing the mod bits and the how do you get to the blocks? 1 yielding 512 times. 1 yielding 512. Okay. Is this correct with the? Oh, she's chewing again. What are you doing, sugar? You know you're not supposed to do that, baby. All right. Maybe there is actually another option, actually, that I do need to actually hash out. There could actually be the okay, so if you're wondering, this camera you're looking at me through is the Canon PowerShot V10. I got it for crazy cheap, refurbished if you can find it. Right now the deals are $320 refurbished. But you put that new firmware on it, oh, it's great. I'm gonna have to say, this might be my favorite live coding camera. Just the quality of the AI green screen is better with this camera. I think they did a good job. Because like if you get a cheaper webcam, the AI green screen doesn't do as good of a job. It's like you need as good of a camera as you can get for the AI green screen because you really want to minimize the motion blur. So you should be at least 1/60 of a shutter speed. And it's going to be optimized. The AI algorithm is going to be optimized for that 1/60th. Let me see. All right. I'm out of time, but I'm allowed to like go over a little bit if I'm like in the flow of stuff. I got to go over to UX design though. I'm going to do the AStartup thing today. I'm just going to focus on the tier repo ranker for Live Coding Alliance because that's I'm having writer's block. So a tier repo ranker, I believe, is oh wait, hold on. I'm not saying this correctly. It's a GitHub repo tier ranker. So you add GitHub repos and then you rank them in tiers. And then I'm going to make these lists that people will make of open source projects on GitHub that they'll rank them, and then we'll have lists and we'll get people to contribute to them. Honestly, dude, I'm actually rather surprised with this this camera. You look at the lights. This is a 1-inch sensor camera from Canon with a this is relatively dark. This is like a very dark table thing. And so this is like the Canon PowerShot V10, 1-inch sensor, but you center crop it. It's like, what is it, 19 millimeter lens, and then you center crop it, and it's like 24 millimeters or something, which is perfect. But I'm gonna have to say the amount of noise coming off of this thing. I mean, look at how little noise there is coming off of this thing. Honestly, I think this is a highly overlooked camera. They're so cheap. You can get them for like, like a little bit over $200 on eBay if you just keep an eye out for them. And I like my studio to be able to turn on all the lights with one switch. My newest thing. Got these soft boxes up here. I got some vase mounts. I like to use vase mounts for my, what do you call it? For my camera stands. Right, this is my document camera. And then, what? Oh yeah, you can take these Vesa wall mounts and you can hook up these soft boxes with using just regular light bulbs. So they're actually really cheap too. The soft boxes with the light bulbs. You can get a Limo Studio 5 bulb model for like $30, and then you can get a soft box for like $60. And I found mine way cheaper on sale, or used. It was both of them were like $25, and then the stand was like $12 used, and then I just needed a little photography stand mount, which you can get in a camera screw kit. Sorry, a camera screw adapter kit. What am I saying? Keep getting distracted. All right. T array begin. That I'm gonna have to change. All right. So I'm willing to change this because you can see I have this TS printer. All right. And why am I using a T string printer? This one has 2 pointers, which are going to be 64-bit. But I could replace those with 2 32-bit offsets using the stack, the ASCII stack. And then start and stop. These are useful, but you can, with an ASCII stack, it's also it's just about as fast. I think this is just a little bit more optimized, but I don't think the memory pattern's optimized. First off, I really, really, really don't like how there's multiple different kinds of strings. I'm perfectly fine with 2 kinds of strings. One of them's for a UTF-32 because you don't have to store the character count because it's UTF-32. It's not compressed. All right. And then you've got another one for UTF-8 and UTF-16 because we don't really have any other way of going about doing this. This is kind of, unavoidable, kind of. It is just the nature of the UTF. So we'll just make the this is the uniprinter. Does this include string f.hpp? Okay, it includes it. It's not going to be terribly difficult to change this out. All I have to do is just put stack and then string. So the string currently is made out of an array. And I think that was just a bad decision. I think I should have, this string printer thing. Okay, what's the benefit of the string printer? Let's say that we error. We have a buffer overflow. All right. Let's say we try to grow the string to be double the size that it currently is. All right, so we got this string printer, which is going to print, and then it's storing only the pointer to the start of the buffer and the stop of the buffer. And this is the most optimized way to print to a string, but it does not store the Unicode character count. You can use it for UTF-8 and UTF-16, but not everything that you print, you need to keep track of the character count. So, one option here is to utilize the ASCII object format. Oh, that's not it. Why do I keep doing that? So with this, when I store the sprinter here, the problem is that there's a big ass buffer. Okay? So I'm going to have to take this sprinter value and I'm going to have to, it's going to be on the stack in a buffer. And then I'm going to have to take that buffer pointer and then I'm going to have to put them back on the stack. And then they're going to get saved again in the hardware assisted stack. All right, I don't think that this is actually the way that I want to go about doing this. It does seem to me I just need to take the plunge because I'm pretty sure that the array was not a good idea. Let's just call it an auto stack. And then do I need with the auto stack is y? So there's no with the stack. I do not have an is y. Is it in here at all? Right. Is y is like your index. So your is z is twice the size of the is y. And so we store the size bytes as the is z because the number of bytes is typically going to be large. You would want it to be larger than the total number of indexes that you have inside of the object. You have to memory align everything, so it's like a trade-off. I wish we could just do the best of everything, but it's like we have to pack up all the data as tightly as possible for extremely large data sets, for like machine learning. And then we have to be able to juggle the functionality of making firmware and then desktop apps. Not terribly difficult with a good data specification. So all right. I don't need to do that. It's hard for me to like try to explain things to people because people, nobody. You guys are like, I don't know who this person is. This stuff really seems really complicated, and then I have to be productive when I'm working, so it's like it's just difficult. And this is an auto stack now. SCK is a stick because string is ST. So auto stack of characters. Oh, so this is only, wait. This is only for either UTF-32 or ASCII. So this is not UTF-8 or UTF-16. So I'm not 100% sure I want to support ASCII. I mean, maybe I could. Oh, big girl needs to stop. Sugar Munch, you need to stop, baby. Stop. She's ruining her bunny house. You know, she like keeps chewing it up. All right, so here's the auto stack. Okay. Works identically. Do I have an ISI? This is an A array. An auto array. I'm kind of confused how this one's working. Oh, I just feed it one extra element. So this is the auto array. So this is at Script2 and ASCII data are contiguous data, data-driven design, data format. So the stack is the first one is the total, the ISI. The second one's the count. All right. So when I make an auto array for a stack, since the first one is the total is in array elements. This is not the number of bytes. This is the array elements. Okay, and then how is that different from the current format? So the current format So what's the thing that you got to do with this? So we have an auto string. We have a set of operator overloads here. This section. All right. All I'm doing is calling the functions inside of the auto string. The print functions that I call, and then it prints using this one. Actually, I'm going to stick this up here. Yeah, fix that. most of this, what I need to look at isn't here. I'm going to print this, and then okay. So what I'm trying to deal with right now is the error handling for when the string print fails, such as I run out of buffer space and I need to grow the string, which is what this code does. So what it appears is that that's not really a problem. So I think that I need to, where's the sprinter? Where is this string printer? This is in the uniprinter. What do we have access to over here? Uniprinter. We don't have access to what I want. String F, string H. Okay, so we don't have access to that here. That's kind of problematic. What? Wait. Oh, that's just string.hpp. This is also confusing. There's string F and then there's string.hpp. So what's the difference? This one has access to the stack. That's the difference. So string F contains your string printer. T string. I guess that's in uniprinter. All right. And so why do we have this one? What is so different about this one? This one is dumb and does not store the character count. So it's useful for when we just want to print as fast as possible. Where's the limitation of not having the character count come in? This class is for when you don't care about the character count. Yeah, I don't know what to say. I do wish I had a bunny cam up. Okay. So the string is another option that I could say is instead of doing this izzy, wait. I might not need to do that because I might just want to do SND. Kind of looks like send. Maybe SRD. And SND is cool. Strand. So what's the difference? One thing that I could do is um, that I could add instead of bytes. I could set. I mean, I could use total. Top. Count. What is the difference between count and top? So top is typically would be count. So count is, or the top is like the place where you can push to. So what do I do? What would I do? So let's say that my print failed. Okay. Then I'm gonna get not cursor. So what's the benefit of this? This is optimized for the fastest possible printing because it uses 3 parameter call. Sorry, 3 function arguments. And this is going to minimize the amount of pushes and pops on your hardware assisted stack machine. And so this is where the sprinter comes from. Is that this is just the most optimized way to I feel like I'd rather return a negative value. So it's nice and easy when you just return the character because then you can just set it. But then I can't tell you what character was the error. That's the one problem with this. I'm not really sure it matters though. This code works pretty optimal. What does that mean for this string? So this thing's what, a stack now? And then what? I get rid of this, right? So what do I do? Auto stack. And then the auto stack works just like the other one, right? It does have an auto array. Sugar. No. Oh. So the sprinter, I don't really need to have a sprinter, right? So this is going to call the constructor on the auto stack. Oh, I think I'll just leave this. This isn't horrible. Wait, where is that? String. .hpp. So I don't do that because the constructor takes care of that. I'll keep the string printer just because it's the fastest way that you could possibly print. So I would prefer to just have one algorithm that does everything, but there's not really much that I can do. I can't really tell you. I can't really can't do what? Reset. What do I do? T string reset. T string start. Huh? T string end. T string stop. Okay, so why don't I have size? Okay, so this isn't right. First off, this thing goes above this thing. Now, stop. One of these is supposed to be constant. Huh? Array T, array N. T string stop. This one I don't need because okay, so what's the difference between the two? So we're gonna have the we got the two different types of strings, one for the UTF-32. That's just a stack of characters. Okay. And then if you want to make a stack of UTF-8 or UTF-16 characters, then that is going to, you're going to use the same bit pattern. So I will take my ASCII bit pattern here. I'll use my vector type bits. Here, I'll create I create an array of characters that's going to be like just a regular array of characters. It's not nil terminated because I want to print arrays of characters to the console or other sources. Because I could just treat an array of signed integers as an array of characters, but it is a need to print just a regular old array of characters. So then we're going to do the stacks. Do I really have to say that? And then the multi-dimensional arrays. So I could do the arrays of multi-dimensional arrays. I'm just going to say those are just arrays of characters, not like arrays of strings. So how do I make an array of strings again? No, there's no loom, huh? So it doesn't make sense to have a map of, let's say, integers or floating point numbers or strings to a array of strings. Boy, 1 o'clock already? I gotta dip out. 16 troll bits. MD and then extended block. Okay. How does this work again? So I have an extended block are created by setting MSB of the 16-bit data type pattern to OB11, yielding 511 types. This doesn't make any sense. 511 types is what? 256 times 2 minus 1, which is 9 bits, right? But that's the thing, is where exactly did I get this? So there's 8, so there's 3 bits, right? 10 LSB, right? So I got upper 3 bits. So I'm just so confused what I did. Because I think I replaced something with something else that's causing a problem. What are the here this guy, the mod bits? Voice. Okay, so is this the one that standard, extended, or context types? Oh, this isn't this the so the maps. We don't create maps of. Okay, so first off, okay, now I understand what's going on. All right, so we have. Boy, this is complicated. All right, so we got a POD table. Then we got the plain context types, A through L. That's 12. All right, and I could remap those types to another type over here. All right, following me? But we have 16 types that are up to 64 bits. And the thing is that the class that we need to use in order to make a map, a sparse map, as opposed to a dense map, of one POD type to another, it's going to require a different type of class. And then we only have 4 of these 128-bit type classes. Doesn't really make any sense to make a map of a 128-bit float to another type. If you ask me, I think it would make sense to do either the signed or the unsigned integer map to another type. The linear ID, this is like exceptionally useful. But the thing is we don't have a full block here. All right, so this is why I was confused. So we set the upper bits. I have an error here. I said you set the upper bits to the extended blocks. OB1 0 1 0. Right, this was my error. Yielding 511 types. This is gonna yielding what, 8 blocks of All right. Extended block types are created by setting the MSB of the 16-bit data type bit pattern to OB110. No, 111. Right, 111. So now I have to make 1, 2, 3, 4. I could just grab 4. I don't really want to do that. So 8-bit signed boolean. I don't know if I really want to do this. So what I could do here, I like the mini float, but it is a duplicate. But it does allow us to. So I have the R-bit void numbers. And those R-bit void numbers are created by setting the mod bits to anything but 0. And extended blocks and context. Let's say extended block. All right. So we still maintain these because I do like these. Because we can treat the characters here as an unsigned integer. All right, it's R bit, so that means it's 13 bits unsigned integer. We could just cast that over to a 15-bit for our 16-bit signed integers. And then we got, I really like the 13-bit float here because it gives us a range that we can activate our neural networks for by storing this float. Taking a little bit of precision out and optimize it for a neural network. I think that's pretty good. So then we got an R-bit void signed integer. Void signed integer is pretty cool. That works. So then we have the standard and the extended block and context types. SEC. Okay, then we go back over here to the extended types, and then the extended blocks. We set the MSB to 1. So how do we create a map of all right, so what are these maps? These are your 128-bit UUID or a universally unique identifiers. These are going to be created by a distributed system. Now, if you just had a synchronous system, the database would create a SQL or something similar column database row index. And ideally, if we didn't have to deal with so many customers, we would just do it like that. But we have distributed systems. So I need to create data and I need to put it into a database. So we use this 128-bit linear ID, universally unique identifier. So, but there's also just a regular 128-bit UUID. And so we want to use the linear ID when we can because it's the superior format for data lookup. It's going to be better for your SQL and it's going to be better for your Redis style in memory. Both of them. It's going to be vastly superior than a microsecond timestamp. So I'm not sure if we need I'm not sure if we really need to have one that's like a difference between I'm not 100% positive that we need a map of a 128-bit unsigned to another type. I believe that when we're working with the 128 bits, we kind of just throw out the unsigned numbers because 128 bits is good enough. We can still do our 128-bit UUID algorithm, but even with your 128-bit UUID algorithm, you really don't want to mess with that sign bit. You really should just throw one of those bits out. So I like the idea of just cutting off the ASCII strings and just going with the UTF-32 with the as a stack of characters, because that I like that a lot. But then we do have the need to keep track of the characters. So it does I like how we could just not have the stack of UTF-8 or UTF-16 characters. I think that works out. Really, with modern CPUs, you should just be using UTF-32. You also have to keep in mind that today's apps are created for internationalization too. So with your UTF-16 and your UTF-8, it's not that much of a bugaboo to have compressed, because you should be internationalizing your strings anyways. So what is going on? I'm just so confused. I'm just overloaded on the different things. So what was the bit? Yeah, the bit pattern. Right. Okay. This one's important. I got to keep on the ball. I had to go pee there. So extended bit pattern type. So it's OB11 because the map type bits are only. Oh wait, hold on. Wait, no, that might not be true. Hold on. Where's my map type bits? I might have to get rid of one of these bits. Okay, so I would prefer to have as many bits on the character as possible, because I really, 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 really want to be able to support as many languages as possible. And utilizing this, we don't get Mandarin Chinese speakers in there, but we get the majority of the Western world in there. So, for me personally, I think that's pretty good. ISV, CHV. So the void float, I want to keep this because a 13-bit float. Kind of like it. So then we would take what? We would have to take one off of here. And then say R minus little r minus 1 bit. So what would we say? We would say that these are extended block. R minus 1 void signed integer. And so this is going to give us, 12-bit signed integer, which isn't very many. I mean, it's better than nothing, but, you get the bits don't come out of nowhere. So it's either that we have to take another bit off of our float, which we have 13 LSB. We've already taken off 3 bits off of our thing. Which is, I mean, it's perfectly acceptable for a neural network, because we want to end up within a range. So 13 bits, we could still store our 8-bit mini float inside of there. And by chopping off the 3 LSB, then Sugar, what are you doing? Why are you doing that, sugar? Baby. You need to stop that. She keeps chewing on her house. Okay. So with the 13 LSB, what do we got for a 16-bit float? All right. Gonna give us what? 10. So we're going from 10 So what this is going to be is that our neural network is then going to have to get trained where this is going to have to turn into like a weight for a neural network with a 7-bit mantissa, which is your fraction, which has your hidden bit. So it basically, essentially, you take off 10 bits, we're at 13 bits, so that's 7 bits, but you have a mantissa hidden bit, so that's an 8-bit value that you can shift up and down 5 bits. Or sorry, 4 bits. So you could take it and you can move it up and down 16 bits, which is pretty cool. Still. All right. I guess I got to get off of here because I'm like, there's just so much technical data here. I'm like overwhelmed.